This topic will take up in number of ways. Pehla, if we have to multiply a vector, so we have multiplication of a scalar with vector. Then we will take up multiplication of vector with vector, जहाँ पर दो cases होंगे या दो types होंगी. One is called as dot product and the other is called as cross product. And then we can extend from two vectors to three vectors, which we'll call as the triple product. So we have scalar triple product, we have vector triple product. Start from here. अगर एक वेक्टर हो हमारे पास a और इस a को मैं एक स्केलर k से मल्टीप्लाई करता हूँ. Obviously, scalar has no direction. This has a direction. What is the possibilities which arise कि क्या k कहीं जीरो तो नहीं, क्या k एक पॉजिटिव स्केलर है या k एक नेगेटिव स्केलर है. अगर k जीरो हुआ then 0 multiplied to a will be a zero vector. Zero vector का जो existence है, this is a very significant existence for purpose of various mathematical operations. और इस zero vector की existence को लेके we have the property कि zero vector is represented by a point. This is a point. This point has no length as such. So a zero vector will have a magnitude 0. That means it will be represented by a dot, but it has an arbitrary direction still. So even if its magnitude is 0, it has an arbitrary direction. Like if I multiply this vector O 0 to A, so it takes the direction of A vector as such. Similarly, we will see its importance when we talk about the cross product of two vectors or cross product of two parallel vectors. अगर A और A हम cross product लें, it will become zero vector. Now, if k is a positive scalar, k times A will be a vector in direction of A. That means the direction does not change, but magnitude changes. But has a magnitude of k times A. That means जो वेक्टर A है इसका मैग्नीट्यूड लें, उस मैग्नीट्यूड को k टाइम्स करें और k जो है एक पॉजिटिव स्केलर है, that will be the result. Similarly, if I have a negative scalar being multiplied to a vector, so I'll say कि if I multiply say a vector A with -2, for example, so what will be the result? The result will be that this will be a vector whose magnitude will be twice of A. That means this vector A, अगर ये पहले vector A ये था, it will become twice in magnitude. This twice in magnitude. So this 2A, but its direction will get reversed. जो ये minus sign है, इसकी direction को reverse करेगा. यहाँ पर क्या होगा कि if I have 2 multiplied plus 2 multiplied to A, so if this was vector A, then this is 2A. 2A will be a vector which will be magnitude wise twice the magnitude of vector A. So multiplying a vector with a scalar has three cases. Case 1, if scalar in itself is 0, then it reduces the vector to a zero vector. Case 2, if scalar is positive, then the magnitude becomes k times, but direction remains same as before. If the scalar is negative, then the direction is reversed and magnitude becomes k times. If k is a scalar with unit, for example, हमारे पास एक common relation जो हम use करते हैं वो ये है that f is equal to m times a. Now m is a scalar, but this scalar, suppose it carries a unit 1 kg. This acceleration, it is meter per second square. तो जो ये quantity है इसका unit बनेगा the product of unit of the scalar m and the unit of this vector, that is meter per second square. So जो force है जिसका unit हम Newton मानते हैं, that Newton is equal to 1 Newton is equal to 1 kg meter per second square. Same is true for this relation. When I say linear momentum is equal to m times v, So this m is a scalar which is positive. When multiplied to v, it carries the same direction as that of v, and magnitude of p is linear momentum, is m times that of v. However, अगर हम ये एक रिलेशन यूज करें इलेक्ट्रोस्टैटिक्स में, that F is equal to Q times E, whether the electrostatic force will take the same direction as that of electric field or no, will be decided by कि क्या हमारा चार्ज जो है वो चार्ज पॉजिटिव है या नेगेटिव है या जीरो है. Since charge can be either zero or positive or negative, so for a positive charge, the direction of electrostatic force will be same as the direction of electric field, whereas for a negative charge it will be opposite. So this way the multiplication of a scalar with a vector is understood in its basic essence, and we go to the multiplication of a vector with a vector. So this is now multiplication of a vector with vector. Here two cases arise. First, we can have dot product or scalar product denoted like this. We can also have cross product or vector product denoted like this. दोनों ऑपरेशंस प्रोडक्ट ही है, लेकिन यहाँ जो आउटकम है when we multiply a vector A to vector B through dot product, ये एक स्केलर क्वांटिटी है. That's why we also call it as a scalar product. लेकिन यहाँ पर जो आउटकम है that is a vector C, which is outcome of multiplication of A and B. So we take up first the dot product. Now in dot product we have a very simple operation which we carry out like this. कि अगर ये मेरे पास नंबर लाइन है, this 0, 1, 2, 3, 4, 5 and 6. Think of 2 into 3 equal to 6. So what we did, हमने 2 का मैग्नीट्यूड लिया, इसको 3 times, 2, 2, 2, 3 times रिपीट किया, we reached 6. Imagine कि अगर ये 2 और 3 दो numbers हैं which do not lie on the same number line, what would be the answer? So think like this, ये मेरे पास अब एक वेक्टर है. This vector, say starting from O, is some vector A, and I have to multiply this vector with a vector B, or these two vectors A and B, they don't lie along the same direction. Think that the angle between them is theta. So what we do is we take projection of this vector B in the direction of A. इसका projection जो ये है, so this is O, this is A, ये है A, ये है O, B. तो point B से, इसके terminal point से हमने एक perpendicular draw किया. It falls along this direction now. So as if we have reduced both of them to the x-axis or along the number line. तो ये जो vector A है, इसका जो ये magnitude है OA multiplied by, ये इस point को मैं C कह रहा हूँ, multiplied by OC becomes A dot B or B dot A, whatever way you call it, it's one and same. A dot B is same as B dot A. Now what is OA? OA is magnitude of vector A. And what is OC? OC now we have to see that what is OC. OC का meaning हम ऐसे निकाल सकते हैं कि I can use the right triangle OBC. So I can say the cos of angle theta, that is cos theta, is equal to base, that is base OC divided by hypotenuse OB divided by OB. So OC becomes equal to OB cos theta, or OC becomes equal to, now you see OB is equal to B, so it is B cos theta. तो मैं यहाँ substitute कर सकता हूँ that I can express now that A dot B is equal to OA की जगह A लिखा जाएगा, A multiplied by OC की जगह B cos theta. So we have a definition, A dot B is equal to A B cos theta. You can think of this definition as the definition of dot product of two vectors. It is magnitude of the first vector multiplied to magnitude of the second vector and cosine of angle between the two vectors, that is cos theta. Now taking the values of theta, suppose theta is equal to 0 degree. देखिए यहाँ पर क्या होगा, a dot b will become equal to ab, because theta is equal to 0 degree. Both these vectors lie along the same direction, so they behave like scalars, as if we have multiplied scalars. If theta becomes equal to 90 degree, this is very important. Sometimes we call it as the test of perpendicularity of two vectors. So if we have two vectors perpendicular to each other, then their dot product is equal to 0. So this is the test of orthogonality or the test of perpendicularity of two vectors. Similarly, if theta is equal to 180 degree, a dot b will be equal to, so ये हो जाएगा a into b into -1, so it will be minus ab. So what we observe here is that dot product of two vectors can be either positive or negative or 0 depending on the value of theta subtended between them. The dot product is maximum when theta is equal to 0 degree. It is minimum when theta is equal to 90 degree and becomes equal to 0. Now, in case of expression of vectors in the form of Cartesian components, we can express dot product like this. तो अगर मैं standard components लेता हूँ, what would be I dot I? So it is magnitude of first vector, that's 1, into magnitude of second vector, that's 1, into cos of 0 degree. So it is 1 into cos of 0 degree. Cos of 0 degree, you understand, is 1. So I dot I becomes 1. Similarly, j dot j becomes equal to 1. Similarly, k dot k becomes equal to 1. So this one outcome is a scalar. But if I take I dot j, or for that matter j dot I, it would be 0 because they are perpendicular to each other. Similarly, j dot k would be 0. Similarly, I dot k would be 0. So this property that whenever we have vectors perpendicular to each other, their dot product becomes 0, that property we are applying. So given a vector A, for example, like this, so I have ax I cap plus ay j cap plus az k cap, then I have a vector B equal to bx I cap plus by j cap plus bz k cap. If you are supposed to take A dot B, you will have to start with this. So first multiply I dot j, I dot k. Then we start with this term ay, j dot I, j dot j, j dot k. So जैसे आप इसको multiply करोगे, you will see कि all those components which are like I dot j or I dot k, they will vanish. Only three components will remain: I dot I, j dot j, and k dot k. So this result will be ax bx plus ay by plus az bz. So given two vectors like this, ax I cap, ax can be now anything, can be a number. So उनका जब आप dot product लेते हैं, simply multiply I with I, that means x component with x component, y component with y component, and z component with z component. That's your answer. So this A dot B would be simply equal to the result ax bx plus ay by plus az bz. The dot product of two vectors as such will be a very significant operation in physics, क्योंकि अगर आप suppose work लेते हैं as a quantity, so work is the dot product of force and displacement. तो जो भी ये properties हमने अभी discuss की हैं, they will be applicable to the definition of work, which is dot product of force and displacement. Similarly, you could think of power as the dot product of force and velocity. We have already talked about potential energy of an electric dipole in electric field as the dot product of the electric dipole moment. This is electric dipole moment and the electric field. And similarly, we have potential energy. So if this is for electrostatic field, this is for magnetic field of a magnetic dipole in magnetic field, it is minus m dot b. So m is magnetic dipole moment, b is magnetic field. तो यहाँ पर ये जितनी भी properties हम use कर रहे हैं dot product की, they become applicable to the equations of this sort in physics. Now we take up the cross product or vector product of vectors. तो यहाँ पर हम दो vectors को multiply करते हैं and these vectors are inclined with respect to each other at an angle theta. Theta can be anything between 0 degree to 360 degree. और think of the situation now कि ये हमारे पास एक है vector A, ये हमारे पास है vector B. The angle between them is angle theta. और angle theta को हम measure करने के लिए by convention एक पॉजिटिव डायरेक्शन इसको मानते हैं कि if we measure angle from A towards B in the anti-clockwise direction, we take it as positive angle. If it is in the clockwise direction, we take it as negative angle. The definition is कि if we take the cross product of A and B, this becomes some vector C. Earlier, the dot product of A and B was a scalar C, but now it's a vector C. Now this arises, ये हमारे लिए एक important situation arise करती है physical world में that we find that two or more quantities they get multiplied to each other and the outcome is a vector, not a scalar. And we'll have ample number of examples from the physical world where we have the quantities combining together, multiplying together, which are basically vectors in nature and yield a vector. In that case we use the cross product. अब यहाँ पर जो ये वेक्टर C है इसके दो एट्रीब्यूट्स है, एक इसका मैग्नीट्यूड है और एक इसका डायरेक्शन है. There is a direction, there is a magnitude. Now magnitude wise we say that magnitude of C is equal to magnitude of the first vector, that is prefactor, then there is post factor. क्रॉस प्रोडक्ट में हम इसके बाद देखेंगे कि देयर इज समथिंग वेरी इंपॉर्टेंट रिलेटेड टू द ऑर्डर ऑफ द प्रोडक्ट. इट्स अ नॉन कम्यूटेटिव ऑपरेशन. इसमें ए क्रॉस बी क्रॉस ए के बराबर नहीं होता है. सो वी मेंटेन द पोजीशन ऑफ ए एंड बी. दिस इज ए बी साइन थीटा. व्हाट इज थीटा? थीटा इज एंगल सबटेंडेड बिटवीन द डायरेक्शन ऑफ वेक्टर ए एंड वेक्टर बी. नाउ डायरेक्शन ऑफ वेक्टर सी इज सच that it is perpendicular to direction of vector A and C is perpendicular to the direction of vector B. How does it happen? It so happens that if I take vector C as the vector along the direction of pen, then I have vector A, vector B, both perpendicular to the direction of pen. That means in this plane, in the plane of board, if A and B lie, vector C is perpendicular to that plane. So we have a complete definition. The cross product of two vectors A and B is a vector C whose magnitude is equal to the product of their magnitudes A and B and sine of angle between them. And also the direction of vector C is such that it is perpendicular to the direction of both A as well as B. Now we use different rules for finding the direction of C, and one of the simple rules is the rule of thumb called as right hand rule. So what is right hand rule now? Right hand rule says that given two vectors A and B, if we take A cross B equal to C, put your right hand fingers in the direction of first vector, prefactor. Now turn it towards the post factor, this post. The direction of C will be given by stretched thumb. So this way A cross B will be equal to C. So A cross B will be equal to C. C is perpendicular to both and I have turned the vector A towards B through smaller angle between them. This is important that we should turn them through smaller angle between them. Don't turn A towards B through the bigger angle. No, through the smaller angle between them. This is right hand rule. So put the right hand fingers in the direction of the first vector. Turn it towards the second vector in the product such that you are turning first vector towards second vector through the smaller angle, then stretched thumb of the right hand gives you the direction of vector C, their product. We can also think of right hand screw rule or Ampere's rule, or we have the Maxwell's rule. So, but they are all, the result is same as I talked about the right hand curl rule. Now think of the unit vectors I cap, j cap and k cap. We can make a relation in writing these products. So we have I cross J, then we have I cross K, then we have J cross K, and so on. There is a very simple way of doing it. We make a permutation like this. So this is I cap, this is J cap, this is K cap, and if I turn from this direction in the anti-clockwise direction, it will be taken as positive. I cross J in the anti-clockwise direction will give us K. K cross I in the anti-clockwise direction, K cross I will give us J. J cross K will give us I, and so on. So let's write it here. I cross J will be plus K because we are going in the anti-clockwise direction. Then we have I cross K. See, here we are going in the clockwise direction. I cross K will be minus J cap. Similarly, J cross K will be plus I cap. You can now turn these vectors by reversing the order in each case. So I can have J cross I is equal to minus K. K cross I is equal to plus J, and K cross J is equal to minus I cap. तो ये जो different vectors के products हैं, that will be useful in finding out the cross product of two vectors. For example, if I have a vector A given by, so I have vector A equal to 2I cap plus 3J cap. I have vector B equal to I cap minus J cap. I want to find out A cross B. A cross B would be like this. So I have 2I cap plus 3J cap multiplied to cross I cap minus J cap. Start multiplying with 2I cap. So I have 2I cap cross I cap. First product. Then I have 2I cap, ये माइनस आ जाएगा यहाँ पर, 2I cap cross J cap, ये माइनस साइन, ये वाला माइनस. Then I have plus 3J cap cross I cap, and then I have minus, ये वाला माइनस 3J cap cross J cap. So this is how. अब यहाँ पर जो दो टर्म्स हैं I cross I और J cross J, they will cancel out, because if we think of the product of I cross I, it is first vector magnitude multiplied by second vector magnitude multiplied by sine of 0 degree, that is 0. Similarly, J cross J is 0, K cross K is 0, and to be more accurate, all these vectors are, this 0 vector which appears here is basically a vector. So in that sense, if we think of this product and this product, they vanish. You are left with minus 2 I cross J. I cross J is K cap. So what I obtain the result here. This result would be equal to, so this result would be equal to minus 2 I cross J is K cap. So minus 2 K cap. Then I have plus 3 J cross I. J cross I is minus K cap. So it will be minus 3 K cap. Finally, your answer is minus 5 K cap. So अगर ये दोनों वेक्टर आप देखो, ये दोनों वेक्टर्स XY प्लेन में लाई करते हैं, और जो इनका क्रॉस प्रोडक्ट है that is perpendicular to XY plane, because direction of this vector is into the board. अगर ये आपके पास X axis है, this is Y axis, then this vector would be inwards. Minus 5K cap would be inwards. That is the expected result. For two vectors in this plane, in the plane of the board, their cross product would be perpendicular to the plane of the board. So we are satisfied with that. Now coming to the triple product, coming to the product of two vectors A and B having three components. So assume that I have a vector A equal to AXI cap, AYJ cap, AZK cap. I have a vector B equal to BXI cap, BYJ cap, and BZ K cap. Now there is a very simple way of determining A cross B. That means that we make a determinant out of these two vectors, taking first row of the determinant as I cap, J cap, K cap, second row of the determinant as AX, AY, AZ, third row of the determinant as BX, BY, BZ. The moment you expand this determinant, you have the cross product of these two vectors. Determinant method has some advantage over this कि यहाँ आपको याद रखना पड़ेगा कि what is I cross J, J cross I या J cross K. Here the things will get generated themselves. और determinant expand करना आपको आता है. If I have to expand this determinant, पहला element हमारे पास है I cap. इसका cofactor जो होगा that will be -1 raised power its row and its column. So it is first row, first column. That's -1 plus 1. Now cut the column, cut the row, make its minor. That minor will be a determinant AY, AZ, BY, BZ. So हमने इसका ये column और ये row और ये column काट दिया. So this becomes the minor. The second term in the expansion will be plus J cap into cofactor. Cofactor होता है -1 raised power इसका row number, इसका column number इस element का. So it will be first row, second column. Now cut the column, cut the row. That is AX, AZ, then BX, BZ. Then we have the third element that is plus K cap -1 raised power. This is first row, third column, 1 plus 3. Cut the column, cut the row. So this gives you AX, AY, AX, AY. Then we have BX, BY. अब इन determinants को expand करें. Let's see. So this gives you I cap -1 raised power 2 is plus 1. So ये हो जाएगा AY BZ minus. So we first multiply along this diagonal, subtract this diagonal, minus AZ BY. Here we have -1 raised power 3 will be -1. So it is minus J cap into along this diagonal. So it is AXBZ minus BXAZ. And finally, -1 raised power 4 is plus 1. So plus K cap into AXBY minus AYBX. If the values of AX, AY, AZ, BX, BY, BZ are known to you, you can get the result here and you can get the answer as an exercise towards the end of this lecture. There will be some problems which you can solve and get the result. Now one very important property of cross product against the dot product is that it is non-commutative. Non-commutative is that if I take A dot B, it is always equal to B dot A. Whatever be the vectors A and B. When I say that A dot B is AB cos theta and this is BA cos theta, you will agree with me that since A and B are real numbers, AB is equal to BA, so the left hand side is equal to right hand side. In that sense, left hand side is equal to right hand side. This equality is always true, so this is commutative property. This commutative property is also held by the addition of two vectors A plus B is always equal to B plus A. And this property does not hold true in case of A cross B, because if I take A cross B, it is not equal to B cross A. This is the breakdown of commutative property. It is not equal to B cross A. Because when I say B cross A, it becomes equal to negative of A cross B. तो जैसे आप इसका order बदल देते हैं vectors का, the negative sign appears into this operation, which means that A cross B is opposite of B cross A. In other words, there may be two vectors same in magnitude but opposite in direction. So remember that cross product is not commutative. Now as far as the additivity of vectors and this commutative property goes, there is sometimes a very important kind of situation. The situation you will meet in case of electric current, you will meet in case of finite rotations, and you will meet in case of time. In all these three cases, there seems to be a direction. There is a direction associated with electric current in the circuit. There is a direction of a finite rotation which may be anti-clockwise or clockwise, say anti-clockwise through an angle of 90 degree, or there may be a direction like clockwise through 180 degree. And similarly, time seems to be flowing from past to the future. But in spite of direction possessed by these quantities, they are still graded as scalars. So the quantities, they even though possess a direction, however they don't follow or obey the property of vector addition. One such property is this, that they don't add in the commutative manner. जैसे अगर आप finite rotations की बात करेंगे of a rigid body, तो ये एक commutative property नहीं दिखाता, so it cannot be graded as a vector. So what is very important is that a physical quantity should be graded as a vector if it has magnitude, it has direction, and it obeys the rules of vector algebra, commutative property, parallelogram law, which commutative property is an outcome of parallelogram law. So this must be obeyed, then only we can grade a quantity as a vector. Otherwise, it's not a vector quantity. In 3 examples को याद रखें. These are the examples of quantities having magnitude, having direction, but not obeying the commutative property or other properties of vector addition. That's why we don't grade them as vectors. Now, in case of vectors, division is not permissible. That means division is not a valid operation in case of vector. I cannot divide a vector A with vector B because magnitudes का division तो हो सकता है, but we don't know how to divide direction of a vector with another vector. So in that sense, the division is a not defined property in case of vectors. We can multiply them, we cannot divide vectors. Now you can pause the video and solve the problems as shown. Also, you can take some more problems of the same type related to this concept and solve them.